So we have no design limitations in producing something. And when I see nowadays that even in an Aldi prospect, in an Aldi folder, a 3D printer is offered in the Christmas sales, we will see in a couple of years that next to the drilling machine in your basement, you will have a 3D printer. That's for sure. And this is what I can forecast already right now here. So we cannot avoid this anymore.
Welcome to EU Defence Declassified, brought to you by the European Defence Agency. This is our podcast where we delve into the world of EU defence. I'm Robin Emmott, and alongside me is my colleague Liga Legstinia. We cover everything from military AI to defence spending and drones, and some of the developments in between.
Hello everyone! Today we are diving into a topic that sounds quite technical, additive manufacturing, but stay with us because it's actually reshaping how militaries work every day. Most people know it as 3D printing, and to help us understand it all, we have two amazing guests. First, Martin Huber, Project Manager, Additive Manufacturing and Logistics here at EDA.
Yeah, thank you very much for having me. Looking forward to discuss with you additive manufacturing.
And we have Frederic Creusen, Innovation Manager at the Dutch Ministry of Defence, who will be working with us here at EDA. Welcome, Frederic.
Thank you very much. Thanks for having me.
Martin, let me start with you. You've been working on additive manufacturing for EDA since 2018. Why is 3D printing additive manufacturing? Why is it becoming part of EU defence?
For the very first time that additive manufacturing has the potential to reduce the so-called logistic footprint. And since then, we are dealing with additive manufacturing within the European Defence Agency. What does logistic footprint means? So that means that we have benefits in reducing efforts and also capacities in terms of warehouses, manpower, logistic supply chain, transport, and all these stuff. So additive manufacturing actually is quite promising.
So essentially, can we say it's about speed and space and convenience? If you can produce what you need right where you need it, that changes the whole logistics situation.
Yeah, actually, that's quite correct, because the characteristics of additive manufacturing is very attractive for, or fits perfect for, armed forces purposes. So we approach additive manufacturing from two directions. The first direction is for, let me say, repair activities. And the second activity is the production of spare parts. So this is how we try to get use of additive manufacturing. Specifically in terms of spare parts, it's very promising because militaries or armed forces are operating assets. They are actually older than 15, 18, 19 years. So they are heading to the end of the life cycle. And we see potential in additive manufacturing to overcome these obstacles in provision of spare parts to keep on operating those legacy assets, these older assets we have.
Thank you, Martin. That's very interesting and insightful. It also really shows us how much we rely on small things behind the scenes. But where would EDA come into all of this? Is the agency running projects to maybe help member states to use 3D printing more effectively?
Yes, of course, it's our purpose and it's our task. We support our member states in their efforts to develop military capabilities. And in terms of additive manufacturing, we have, let me say, set up 3 work streams on AM. The first work stream is a so-called Category B project, which is a project together with member states experts, where we elaborate and determine common standards just to set up the base for common activities on additive manufacturing. This is very important. Otherwise, we would not be able to support each other to achieve interoperability and interchangeability of the AM solutions we are going to produce. So that's the first work stream. The second work stream is more, let me say, an academic one. It's a symposium we are going to conduct every 3 years. And we invite experts from universities, from industry, but also from armed forces to discuss additive manufacturing in context of armed forces. And last but not least, and this is the most challenging one and the most interesting one, it's a 5 days workshop we call Additive Manufacturing Village. We are actually running it every 2 years. Now we are heading to the 3rd edition of AM Village. It will be in March in Albacete in Spain, hosted by the Spanish Air Force. And in this workshop, we try to introduce additive manufacturing to armed forces logistics. We welcome industry partners for the transfer of experiences. And what we want to achieve as well as We want to build up a community in trust to foster the implementation of additive manufacturing technology.
And in Ukraine, we've seen 3D printing used in very pragmatic ways, such as spare parts, production of drones. I was wondering, Frederic, to bring you in, from your materials standpoint, what's being done there in Ukraine, and what does that tell us about the potential of this technology?
What we currently see is that Ukraine is able to provide Essence with legacy spare parts to get them rolling again, which is an incredibly important facet of additive manufacturing at the moment. Really, to have these older systems that don't have any more suppliers or that are not being repaired properly to produce parts that are currently not available on the market is really a game-changing asset for the Ukrainians at this moment.
And do they have a user manual, or how, if it's not being produced, how do they know what to produce?
So this is a very good question. Most of the parts that are currently being additive manufactured are reverse engineered. So an engineer or a technician will look at the part. He will, with his knowledge, try to guess the best material, the properties, how it should be drawn. And he will most likely make a CAD drawing, a computer-aided design drawing. And then he will generate a file that is ready to be printed. And the engineer itself also has to select the right process, the 3D printing process, because there are various. Some are more complex, some are more simple, and each process has its different types of characteristics. So it's really a very complex world where the engineer has to do everything, but in the end, it is a very capable asset to have in your maintenance folder.
Thank you.
I think also what you're saying, it's really a good reminder of how this war is also driven by technology, and also this ability to come up with fast and practical fixes is becoming increasingly important. But Frederic, in your role at the Dutch Ministry of Defense, you deal with many emerging technologies. How does additive manufacturing, or so to say 3D printing, fit into this bigger picture?
So what we currently see is that from the commercial side, from the consumer sides, a lot of new technologies emerge, which are also interesting for the ministries of defense. So a very obvious one is the use of drones, which has been quite prominently introduced by commercial partners. And the Ministry of Defenses are adopting these technologies for their own use. And then additive manufacturing is also one of them. We've seen very small and easy to use desktop printers being bought by maintenance units and teams to supply spare parts. And this is something that is really commercial driven. And this is also what we see at the Dutch MOD and at my innovation unit, that we try to adopt lots of these commercially and consumer driven technologies.
Oh, fantastic. And Martin, we'll see one day 3D printing units deploying with troops. Is that something we are looking into? And perhaps also to ask, could we eventually see, say, trained teams who can carry out printing and repairs directly in the field, on the battlefield?
Yes, of course. Actually, this is one of our strategic objectives to achieve, but we can see that already right now. And the focus on, or let me say, the scope of additive manufacturing was widened into combat and agile logistics. So that means having deployable solutions available are for an immense importance for the armed forces. Also reflected and from the lesson learned we have seen in Ukraine. So we will see more and more deployable containers, because this is the standard tool we use in the military logistics, a 20-feet container. And we will see the containers, they have more and more equipment available just to perform additive manufacturing solution in this regard.
And Frederic, actually, it makes me think, if 3D printing moves closer to the front line, what challenges would that create on the materials side exactly?
Like I mentioned before, you have several types of 3D printing technologies and capabilities that you can use. Some are more complex and more heavy. Some are lighter and more deployable. What we're looking into is to get a system that is as simple as possible into the field to make it also easy to operate by any user. But then the challenges emerge that we need to ensure that the properties from these 3D printers are the same as the original parts. And this is currently, from a material science and engineering perspective, one of the largest challenge to really get the same properties as the original parts with the 3D printed parts.
Yeah, we've talked a bit about materials. What would be examples of the inputs? Are we talking steel, concrete, plastics?
So we can print lots of materials, so steel, plastics, concrete, you name it. But like I said before, the material properties and the complexity and the ease of use of the systems are all parts of the equation. So currently, the most easy to use systems are polymer based, so plastics, and we can reach a certain quality with plastics. But at some point, once you get to more heavy machinery, more critical systems or components, we need to move to steel or metal 3D printing. But the problem is there that these metal based 3D printers are much more heavy, much more complex to operate. So we really need to identify where in the logistic chain we can place a metal printer or, for example, a plastic printer.
And actually, this is the biggest benefit of additive manufacturing futures also. And this is aligned with some European strategies on critical raw materials, for example. We can maybe replace metal solutions by polymer solutions by using very disruptive technologies from polymers instead of metal. So this is getting independent from the suppliers of critical raw materials.
Yeah. And this is a very interesting point from my engineering perspective, because what Martin says is totally true. At some point, we can maybe develop plastics that have proper properties that maybe can match metal components. And also these plastic systems are more easy to use than the metal 3D printing systems. And that would be a huge win once we can use simple plastic 3D printers to produce parts that are as good as the metal components that we want to replace.
It's very interesting. Also, I would say futuristic in a way. I think you also started to introduce my next question. Actually, Martin, I wanted to ask you, with all these new materials and printing techniques, what would be the most surprising or maybe even futuristic application you see coming to the logistics world?
I think that concrete printing is quite promising at the moment. We are approaching concrete printing for force protection currently. So we see, just imagine nowadays, if you have a bunker or a kind of a special wall to protect your forces, we call them T-walls. And let me say they have a specific physical resistance. We see now in shaping new designs. This is actually one of the highlights of additive manufacturing, or the strongest point of additive manufacturing. You can print new shapes, new forms, okay? And we see a potential to improve the force protection character of concrete printing. And it has another aspect. On the one hand side, it has the potential to reduce also here, for force protection reason, the logistic footprint. Imagine if you have a deployment anywhere to this world and you have to establish a base or build up a base camp and you have to protect it by concrete walls. You have to ship and transport all these walls from A to B. And it's a huge logistic effort and a huge cost factor as well, and the time factor. But now imagine with these printing machines, you can produce on site immediately, and you have even an increase of the force protection. That means blast and shoot effects that can be eliminated or decreased.
Yeah, that's actually something we saw in Afghanistan, right? The need to bring these huge T-walls across from Europe and put them there in the desert. And you're saying that would no longer be necessary.
Exactly. So we were shipping thousands of tons of concrete walls to Afghanistan to protect our militaries there. And this is a huge aspect of reducing the logistic footprint. So this is definitely promising.
And Frederic, is there anything futuristic that stands out for you? Anything that you've read or seen that surprised you in 3D printing?
The thing I would deem most promising would probably be the use of high performance polymers, like we just mentioned. For example, the use of polymers as a replacement of metal parts. And yeah, I think that would be my most interesting take on that.
Okay, thanks. We're nearly out of time, but I had a question to both of you, if I may. I mean, it is a complex field. You make it sound straightforward and easy, but I'm wondering if there's one thing about additive manufacturing in EU defense that you would like our listeners to remember. What would it be? Martin, let me start with you.
I wouldn't say remember, but I use a glass bowl and I'm looking into this glass bowl. And let me say, additive manufacturing is a technology which has game-changing character, exactly as a couple of thousand years ago when human beings were inventing the wheel. So we have no design limitations in producing something. And when I see nowadays that even in an Aldi prospect, in an Aldi folder, a 3D printer is offered in the Christmas sales. We will see in a couple of years that next to the drilling machine in your basement, you will have a 3D printer. That's for sure. And this is what I can forecast already right now here. So we cannot avoid this anymore. It will come.
And Frederic, will you be buying a 3D printer for your basement?
I already have one.
Excellent. And what's the thing for you that's most striking or you'd like people to take back with them when they finish this podcast?
So I would like to encourage everyone with some technical affinity to focus on 3D printing because it's very likely going to be a disruptive technology in the coming years.
In what sense do you mean disruptive?
In the sense that we will most likely not be dependent on the traditional supply chains, but we will be able to produce a certain amount of parts at home or on a workshop or in the field or in a expeditionary setting instead of buying them from abroad or buying them online, etc.
Okay, thank you for the explanation. Maybe it will be on my Christmas list as well, a 3D printer. But actually, that brings us to the end of this episode. Thank you to our guests, Martin and Frederic.
Thank you very much.
Thank you very much for having me and hopefully see you soon.
We hope you enjoyed EU Defense Declassified. For more information on our work, visit our website at eda.europa.eu and check out our magazine, European Defense Matters. It is genuinely a great read. Thank you for listening and stay tuned for more episodes.